Okay, one, two, three.
Hello everyone, my name is Arslan and I am presenting the final term project. IoT based smart healthcare system for employees based on support vector machine. My keywords are machine learning, training data and identification. So the description of the keywords is support vector machine is a machine learning sort of algorithm in which we firstly train a support vector, a machine with some input data which contains, for example, if we need to train video based data, then we need like more than 10 to 15 videos depending on the frame rate and number of frames that they contain. Then after the training is completed, then we do the analysis through the help of the support vector machine. So machine learning contains support vector machine, artificial neural networks and probabilistic neural networks. Then second keyword is identification. Identification can be anything like anomaly detection or some disease detection as it is related to healthcare. And training is, as I already explained, related to support vector machine. So okay, making the idea was machine learning, identification and training data, three keywords. When we put them into IoT and combine them with e-health, this is how I have understood my topic. So healthcare, what is the importance of healthcare in IoT? Healthcare is, present day healthcare is about remote patient monitoring and remote doctor consultancy. So health data exchange, some sort of a database, and all the nodes which are, for example, patients, doctors, insurance company, they are all connected with this database and they are handled through this database, which means that remote patients can be monitored remotely, they can be cured remotely or even operated remotely. So as healthcare systems already exist, so in healthcare systems the main idea is providing smart images because patients' privacy and compliance policy is the main problem. Because in any patient's data, for example, we have an X-ray or we have some MRI, we need to hide the patient's data due to compliance policy. So when as it will be some sort of a data exchange, so all the patient's data will be transmitted from one node to the other node. In this transmission, there can be some leakage of data and someone can steal the data and use it for some other purposes. So the importance is to secure the data. So what we do is we use image steganography. This is the basic concept of image steganography, which let me explain in further slides. So support vector machine is used for classification and detection, but and this is some example of support vector machine in healthcare systems. So the benefits are that firstly it is greater and fast. Mainly it is accuracy, as when we are dependent on support vector machines, machine learning, then the accuracy is much higher. Then further, for using the healthcare central database, it will be benefit is the reliability, faster communication, and plus we can keep a good trace of history of the patient's data. So these are the 5 steps of RTS designs. So the stimuli is employee data, as my proposal is about smart images related to patients. So it can be medical images or videos. Timing constraint should be less than 10 milliseconds. This is normal timing constraint for a network. Then system function is the number of nodes. Design algorithm is medical image or video analysis, that is diagnosis for the disease or something. And scheduling is first in, first out. So these are the types of steganography. This is least significant bit matching, least significant bit matching revisited. I will just explain these two quickly. In this one, what we do is normally in one pixel there are three channels, R, G, and D. Each channel has 8 bits of information. What we do is we use the two least significant, which are the two rightmost bits. We remove them and use them as other information bits. It can contain the patient's secret data or its diagnosis, its name, or anything. And least significant bit matching means that the two bits which are exactly same as our secret message, they are used. In this way we don't have to distort the image at all, we are using the same bits. So these are the results. For example, this image is capsule endoscopy. For example, we want to hide this information. This picture is a property of Bain's lab, please do not copy. We hide this information in this picture. The quality of the picture remains the same. This is 62 dB, peak signal to noise ratio, and you can see that the hidden information is present in this picture and the quality is exactly the same. So ultimately, main motive of this work is that smart images can be used for keeping privacy of patient's data. For example, this image, it can contain all this information. Normally in our existing healthcare systems, what we do is, for example, if we are transmitting some image already, there is some extra file with it that contains the patient's data, so we can put this patient's data into the smart image, then transmit it. This way we can keep the compliance policy and for privacy for the patient. So that's all. Last.